Have you ever had a great idea and wondered, how could I make a computer do this? Well, today we're going to pull back the curtain on that exact process. We're going on a pretty incredible journey, following a single thought all the way from your mind into a working program that a machine can actually understand. So let's get started.
Okay, so here's the big fundamental question, right? At their very core, computers are shockingly simple. They don't understand words or concepts, they only get machine language. Just a long stream of zeros and ones. So how in the world do we bridge that huge gap between our complex human ideas and the computer's super basic binary world?
This is really the heart of the communication barrier. You've got machine language on one side, pure binary. It's lightning fast for the computer, but for us humans, it's an absolute nightmare to try and write or fix. But on the other side, you've got high-level languages. These use words and structures that feel a lot more like English, which makes them way easier for us to work with.
And you know, to solve this problem, we've basically built layers of abstraction over the decades. Back in the 40s, it was all pure binary. Then, by the 50s, we got symbolic languages, also known as assembly, which use these short codes called mnemonics to stand in for instructions. And that paved the way for the 60s and the explosion of high-level languages, which finally let us focus on the problem we're actually trying to solve, not the nitty-gritty details of the machine.
And that brings us to the star of our show today, the C programming language. Developed way back in 1972, C is this amazing high-level language that strikes a perfect balance between raw power and readability. It's efficient enough that you can write entire operating systems with it, but it's still accessible enough for us to write our own cool applications.
Now, before our C program can actually do anything, it needs a stage to perform on, right? So let's take a quick look at the computer's anatomy, the hardware and software that really bring our code to life.
First things first, you've got the hardware. Just think of this as the physical stage, the lights, the curtains, the props, basically anything you can actually reach out and touch. This is the tangible stuff where all the action is going to happen.
And the main actors on this stage, well, you've got the CPU, which is the brain of the operation, doing all the thinking and the math. Then there's memory, or RAM, which is like a temporary workspace that holds the script, our program, and any data it needs right now. And of course, you have the input and output devices, like your keyboard and screen, which is how we actually talk to the show.
So if the hardware is the stage, then the software is the director of the play. It's the set of instructions that tells all those hardware components exactly what to do and when to do it. You can't touch it, but without the software, nothing happens. It's what makes the whole show run.
And what's really cool is how it all fits together in layers. As a user, you're interacting with an application, right? But that application doesn't talk directly to the raw hardware, no way. Instead, it goes through the system software, your operating system, like Windows or Mac OS, which acts as this master coordinator, managing everything behind the scenes.
All right, the stage is set, the actors know their roles. It's finally time for us to write the script for our play. We're going to write our very first, very simple C program.
Let's start with a really simple idea. We just want to add two numbers together. When we translate that thought into C, it looks something like this. It's just a precise step-by-step recipe for the computer to follow. Now let's break down one of the most important parts of this script.
A really key concept here is something called a variable. The easiest way to think about a variable is like a labeled box. In this example, we're basically saying, hey computer, give me a box, label it Tay, make sure it's for holding whole numbers, and then go ahead and put the number 40 inside. It's just a named spot for our program to store stuff.
And this gives you a great look at the program's overall structure. Now there are a few different sections, but the one you absolutely have to know is the main function. Think of this as the curtains up signal. As soon as you run your program, the computer's first job is to find main and start following whatever instructions it finds inside those curly braces. That's the starting point.
Okay, so we've written our script in C, but right now it's really just a plain old text file. The computer still has no idea what to do with it. This is where the magic happens. We've got to go through this crucial translation step to turn our script into the zeros and ones the machine can actually understand.
This whole process is called the C compilation model, and it really is like a sophisticated factory assembly line. Our human-readable source code goes in one end, and a ready-to-run, fully executable program comes out the other. And the master translator in charge of this whole operation is a special program called a compiler. This assembly line has four really important stages. First, the preprocessor gets everything ready, kind of like a setup crew, handling some initial prep work on our code. Second, the compiler does the really heavy lifting, translating our C code into that low-level assembly code. Third, the assembler takes that assembly code and turns it into binary object code. We're talking actual zeros and ones now. And finally, the linker acts like the stage manager, grabbing our object code and pulling in any other pre-written code it needs to create that one final executable file.
And this table gives you a super clear picture of that whole transformation. See? We start off by writing our source code in a text editor, which creates a file ending in .c. Then, the compiler crunches that into a .obj file. That's the object code. And finally, the linker bundles everything up into a .exe file, the actual program you can double-click and run.
You know, a program that just runs straight from top to bottom isn't all that useful. The real power, the real magic, comes when we give our code a brain, the ability to make decisions and to repeat actions automatically. Take a look at this flowchart. This is for something called an if-else statement, and it's basically a fork in the road for our program. The program gets to a point where it has to ask a question. If the answer is yes or true, it goes down one path. If the answer is no or false, it goes down a completely different path. And here's what that fork in the road actually looks like in C code. It's pretty straightforward. We use the keyword if, and then we put our question or condition inside the parentheses. If that condition is true, the code inside the first set of curly braces gets executed. Else, if it's false, the code in the second set runs instead. It's simple, but it's incredibly powerful logic.
Now, what about doing things over and over again? For that, we use loops. This flowchart shows a while loop, which is an amazing tool for automation. Here's how it works. The program checks a condition. If it's true, it runs a block of code. But then, and this is the key, it loops right back around and checks the condition again. And it'll keep doing this cycle over and over and over until that condition is finally false. Then, and only then, does it break the loop and move on.
And just like that, we've reached the end of our little journey. We've successfully taken a simple idea, a thought, and transformed it all the way into a set of instructions that a machine is now ready to execute.
So, when you really think about it, this whole journey is a process of transformation. We started with a human idea, we expressed it using the specific grammar and rules of the C language, we used a compiler to translate that script into the computer's native language, and then we gave it a brain by adding logic for making decisions and repeating tasks. This is the fundamental cycle that powers pretty much all the software you've ever used.
So we've just seen exactly how an abstract idea can become a concrete running program, how a simple thought can be turned into a real action. This process, it's the bridge between our imagination and reality. So I guess the only question left to ask is, what incredible idea are you going to bring to life next?